ESS Intro to Resources Part 6. After an initial review of carrying capacity, we'll focus on the ecological footprint. The ecological footprint represents consumption of resources in land area equivalents. If we can visualize the land area required for our consumption of resource and be shocked at its magnitude, maybe people might be moved to reduce consumption. The significant ideas are environmental indicators and ecological footprints can be used to assess sustainability. The ecological footprint is a model that makes it possible to determine whether human populations are living within carrying capacity. Human carrying capacity is difficult to quantify. Here is the outline of all the available movies for the Introduction to Resources unit. Use this outline to find the movie you need for review. This movie is focused here. This is the first of 2 movies on ecological footprint. Your ecological footprint is a measure of your consumption of resources. How large is your ecological footprint? I'm going to open this movie with a review of carrying capacity because carrying capacity relates to ecological footprint. Now, you should be able to define carrying capacity as the maximum number of individuals that can be sustainably supported in a given area. As you read the definition for carrying capacity, it's important for you to focus on what the environment can support sustainably over time. While carrying capacity is a number per area, your eye should linger with the concept of what the environment can provide in the way of resources. As a population grows towards carrying capacity, density-dependent limiting factors slow the growth and serve to maintain the size of the population around carrying capacity. For wild species, availability of food, predators, disease, nutrient availability, light are all important density-dependent factors. For humans, resources such as food and water are critical density-dependent limiting factors. The implications of continued human population growth are reduced availability of resources, food and water, and this could lead to conflict or migration, as well degradation of the environment, together with the consumption of finite resources, are expected to limit human population growth. As we consume resources faster than they are replaced, and we release wastes at rates faster than the earth can assimilate those wastes, we degrade the environment. This degradation will limit human population growth. As we consume resources faster than they can be replaced, we degrade the environment. This degradation will limit human population growth. And when humans consume resources faster than natural replacement, we could exceed carrying capacity if we haven't done so already. If humans do not live sustainably with the resources provided by the earth around them, they will exceed carrying capacity. Is the current number of 7.5 billion people below Earth's carrying capacity? Or are we here, having already exceeded carrying capacity as we harvest at rates faster than natural replacement, shrinking available natural capital? And what are the implications of our continued growth? Carrying capacity cannot be exceeded indefinitely. So now consider the carrying capacity of local environments, specific local environments. Are local populations living within carrying capacity or exceeding carrying capacity? As we shift toward an examination of ecological footprint, I want you to keep your eye on the carrying capacity of different environments around the globe. So here is the definition of ecological footprint. It's an area of land that would be required to sustainably provide all of a population's resources and assimilate all of its wastes at a given standard of living. The ecological footprint is a model all consumption transformed to land area units, and the ecological footprint includes the assimilation of all wastes. But the ecological footprint is always an underestimate of real consumption, because how can we account for water or resources that come from the ocean in land area terms? The ecological footprint is an area of land that would be required to sustainably provide all of a population's resources and assimilate its wastes. And the footprint, this area of land, includes the land for crops, land for timber, the wood that's consumed, land for the buildings, our urban footprint, carbon sequestration. This is land area to take up the carbon dioxide, some of the wastes that we're responsible for, land for animals, for our meat, and for fisheries. And it's important to note before I leave this slide that when the ecological footprint is greater than the land area available to the society, that society is living unsustainably. So while carrying capacity represents the number of individuals per area, ecological footprint is the reciprocal of carrying capacity. Let's take a look. Ecological footprint is the area per the individuals in the society. It is the land area equivalent that provides the resources required by the society. Once again, ecological footprint is an area of land that is required to sustainably provide a population's resources and assimilate all of its wastes. Now, key ideas in this definition: sustainably provide resources and assimilate wastes. Part of a society's footprint is the land area to take up the wastes. If the waste stream is high, the footprint will be larger. If the waste stream is low, then the footprint will be smaller. Now, the ecological footprint is a model, and it's used to estimate the demands that human populations place on the environment. And all the consumption, those demands, represented as consumption, are transformed into land area units, typically a hectare. So how large is your footprint, or the footprint of the society to which you belong? You can see that the size of a society's ecological footprint is dependent on lifestyle choices. How much fossil fuel do you consume? How much wood or paper do you consume? How much meat do you eat? And wastes, land area to take up the CO2 from fossil fuel burning, must be part of the land area footprint, as the ecological footprint model has sustainability as part of its core. For a moment, let's return to consider the entire Earth and the world's population. The Earth has approximately 11.2 billion hectares of biologically productive land. That's usable land, forest land, grazing land, waterways, and built upon land, our urban areas. So how much land area does the Earth have for each one of us? With all of the usable land, 11.2 billion hectares, divided by the world's population, there are 1.6 hectares per person. This is approximately 4 acres per person, if you prefer acres as a unit. Now, the complicating issues are the average amount of land per person gets smaller and smaller when more and more people come into the world. Secondly, not everyone consumes the same amount. So for every person that consumes more than the 1.6 hectares can provide in terms of resources, someone else, somewhere else, must make do with less. Now notice that ecological footprints can be calculated by country on the basis of local consumption patterns. Notice that more economically developed countries have huge footprints. Now, large footprints would be fine as long as the land area is there to support high consumption with the assimilation of all wastes. If it's not, if that land area is not there, then the population is exceeding carrying capacity and not living sustainably. Now, one last thing. It's important to remember that the productivity of the land is not equal from one country to the next, and this issue is important. More on this later. Keep an eye for it. Now, as you remember from earlier work in this course, more productive land would support more people, and less productive land, less people. The carrying capacity of the productive forest is higher than the carrying capacity of the unproductive tundra or desert. Now, remember, ecological footprint is the reciprocal of carrying capacity. So, if a population of people living in a biologically productive region, Brazil for example, the per capita footprint would be smaller in this biome than for a population of people living in an unproductive region, such as a tundra or desert region. Because the land is not productive here, more area would be required to supply each person with their needs. Keep this idea in mind. And I can't go any further in this movie without noting that ecological footprint calculations are always underestimates of the area required for all resources consumed, because it's really not possible to account for all aspects of consumption. How do we represent fish or water consumption in land area terms? Now, I want you to be evaluating ecological footprint calculations for their limitations as models, as they are always underestimates due to the complexity of consumption patterns. Now, as you look at this image, I want you to consider your lifestyle choices or the choices of the society to which you belong. How large is your footprint? So let's take a look at the ecological footprint of the Netherlands. You can see the Netherlands here. Take note of its area. And here is the Netherlands' ecological footprint, 20 times larger than the actual size of the country. Now, how is it possible that the land area to support all of the people of the Netherlands would be larger than the actual area in the Netherlands? The answer is that resources flow from other parts of the world to the Netherlands, which results in an ecological footprint that is larger than the area of the Netherlands itself. In a sense, the people of the Netherlands borrow land area from other locations. The magnitude of the ecological footprint of a country is dependent on per capita consumption. More consumption means a larger footprint. The population size, more people means more consumption, which results in a larger footprint. And the local productivity, the MPP, because we would calculate the footprint using local productivity values. The more productive the region, the smaller the footprint. The less productive the region, the larger the footprint. Now here's the ecological footprint analysis of the lower Fraser Valley in British Columbia, Canada. You can see the actual area of the lower Fraser Valley here, while the ecological footprint is here, 19 times larger than the actual area. The magnitude of the ecological footprint of a country or a region is dependent on per capita consumption. More consumption, the larger the footprint. Dependent on population size, more people equals more consumption, thus a larger footprint. And local productivity, NPP, because we would calculate the footprint in land area terms using local productivity values. The more productive the region, the smaller the footprint. The less productive the region, the larger the footprint. So here are the relevant IB syllabus statements. Explain ecological footprint as a model for assessing the demands that human populations make on their environment. Explain the relationship between ecological footprints and sustainability. One's level of resource consumption depends on lifestyle choices, your energy consumption, material consumption, travel. What is your environmental value system? Are you ecocentric or technocentric? The ecological footprint of a country is dependent on the per-person consumption. Societies that are more vegetarian would have a smaller footprint than societies that are more carnivorous. Large ecological footprints result from big cars, fancy lifestyle, high consumption of goods, a lot of traveling by plane, and due to the high consumption of everything, a lot of waste, carbon dioxide, for example, that needs to be assimilated by the Earth, thus increasing the size of the ecological footprint. The ecological footprint of a country, or the per capita ecological footprint for a citizen of a country, is dependent on local productivity. A less productive area, as you can see in this image, would require more land to provide necessary resources, such as food, for the people living there. The people living in this region would have a larger ecological footprint than a society located in a more productive area. When an area is productive, high NPP, it can support more people. So the area per person requirement for resources is less. The ecological footprint for people living in the region depicted in this slide would be smaller than for people living in a less productive location. But don't forget that the ecological footprint of a country is dependent on the number of people that are there, because more people would consume more resources, thus increasing the footprint. Keep this in mind when considering the ecological footprint of an entire country or a region, as I've done in the previous slides with the Netherlands and the Lower Fraser Valley in Canada. The ecological footprint of the society with a large population in an unproductive region is going to be larger than the ecological footprint of the society with the small population in the productive region. One society is living sustainably, the other one not. Dubai is located in a desert biome of the Middle East. The city has many people in an unproductive biome. The people of Dubai are living in an unsustainable manner. If human populations do not live sustainably, they will exceed carrying capacity and risk collapse. So as I get close to bringing this first of two movies on ecological footprint to a close, this is the perfect time to review a concept I introduced when we studied populations. The concept is, can you explain the difficulties in applying the concept of carrying capacity to local human populations? In the discussion of our uncertainty of local carrying capacity, I would like you to include the following factors: the range of resources used by societies, that societies can substitute one resource for another, that there are variations in lifestyle choices, societies can import resources, and there are technological developments that change the status of resource availability. From location to location, there is a wide range of available resources. Depending on resource availability, local carrying capacity will vary. There is a wide range of available food resources. Depending on what's available, how it's grown or harvested, carrying capacity will vary. The second factor that contributes to the uncertainty in knowing carrying capacity for local populations is that humans have ingenuity. In other words, humans can substitute one material for another, and this influences local carrying capacity. Humans have substituted aluminum screw-on caps for cork stoppers. In providing fabric, humans have substituted cotton for silk, nylon for cotton, and Gore-Tex for nylon. The third factor that contributes to the uncertainty in knowing the carrying capacity for local populations is that society lifestyle can vary. The choices people make will influence local carrying capacity. Depending on how each one of us consumes, carrying capacity can go up or down. If we each consume huge quantities of resources, carrying capacity would go down. But if each of us were to choose to consume less, carrying capacity could theoretically go up, as there would be more resources to increase the population size. People can choose to eat higher or lower on the food chain. People can choose to eat more or less processed food. These choices affect local carrying capacity. Meat-eating cultures are high consumers because of the 10% rule that you learned when we studied ecology, that only 10% of everything a consumer eats remains as net secondary production. Thus, every 100 kilograms of grain fed to cows results in only 10 kilograms of cow meat that is made. By eating meat, we are wasting grain that could be fed to others, thus decreasing local carrying capacity. People make decisions about whether or not to recycle, to carpool, to turn off the lights when they leave a room. These decisions impact local carrying capacity. Reduce, reusing, and recycling are important for resource conservation. And by not wasting resources, there are theoretically more to go around. By these activities, carrying capacity would be increased. The fourth factor that makes us uncertain about our understanding of local human carrying capacity is that local populations can trade for resources. This would allow a local population living in a region with a naturally small carrying capacity to increase carrying capacity by importing resources from a distant location. Think Dubai, Las Vegas, big cities in the desert. These houses are located in a tundra biome. The wood to make these houses was imported. The fifth factor that makes us uncertain about our understanding of human carrying capacity is technological development. Through technological advancements, humans have been able to produce more food per square meter, allowing for an increase in the carrying capacity, not just once, but twice and 3 times. Tools allowed humans to better hunt and gather food. Domesticating crops and animals increased carrying capacity, and the Industrial Revolution, with fossil fuel-driven farming techniques, including fertilizers and irrigation, this has stimulated the exponential growth in the human population over the last 100 years or more. What new technologies might arrive, allowing humans to increase the kilograms of food harvested per square meter of land? Gene technology? Fertilizers, irrigation, and hybrid seeds were the driving forces in the Green Revolution. Truthfully, cheap fossil fuel was also very important. These technologies increased food supply, thus allowing for the exponential growth in human populations over the last 150 years. These technologies increased the Earth's carrying capacity. Can we do it again? In providing light, technological developments have brought us whale oil, then coal, then nuclear power. And here's a summary of the ideas that swirl around the difficulties in understanding the concept of carrying capacity as it's applied to human populations. You can pause the movie now and study this list, as I won't review it any further. And that brings us to the end of IBESS Introduction to Resources, Part 6.